Lesson 110, we're going to solve problems that include rational numbers. In example 1, we're going to talk about a boat. It is in a lock that has water draining steadily from one lock to lower a boat from one level to another. The boat lowers 3 feet in 4.5 minutes. What is the boat's change in position per minute? Let's use a picture to describe what is happening to help us solve the problem. So using a picture, we know that the boat is lowering 3 feet in 4.5 minutes. So we could look at this as 4.5 minutes and block it off. 1, 2, 3, 4.5. That minutes that covers these 3 feet. We could also decide what operation that we might use to figure out this problem. We're trying to find out what the change in position is per minute. So we need to know what amount of feet this boat is lowering for each minute. So we could divide. We could simply divide the distance per minute. And this is pretty common. If it has something like per, we're looking at the change in position or the distance per minute. So it's a division problem. And we're going to divide the 3 feet that it lowers. Lowering means that it's -3 by the change in time, the number of minutes, 4.5 minutes. We could rewrite that as dividing two fractions. -3 could be rewritten as -3/1. And then 4.5 could be changed to a fraction by saying 2 times 4 is 8, plus 1 is 9, so we get 9/2. Remember, when we divide fractions, we can change it to an equivalent multiplying fractions problem. So we have -3/1 times 2/9. We could follow through with multiplying. -3 times 2 over 1 times 9. We get -6/9, which does reduce to -2/3. So the change in position is -2/3 of a foot per minute. If you look here at the picture that we drew, you could tell that each minute was going to be less than a foot. So -2/3 is less than 1 whole foot, so this seems to be a reasonable answer. Example 2, Kevin had 12 answers correct and 8 answers incorrect on a trivia game. Each correct answer is worth 2.25 points, and each incorrect answer is worth -0.5 point. What was Kevin's score? Well, we could start with the fact that Kevin had 12 correct answers that were worth 2.25 points each. So we see he had 12 answers correct, and each correct answer is worth 2.25 points. So let's take 12 and multiply by 2.25. That'll give us all the points for his correct answers. We also see that he had 8 answers incorrect, and each incorrect answer is worth a -0.5 point. So we have 8 incorrect answers times -0.5 point. And we could just add his correct answers to his incorrect answers to find out what his total score was. So we can go through and figure this out. I'm going to go over here to the side because I'm dealing with some multiplying fractions. And I'm going to say I have 12, which we could rewrite as 12/1, times 2.25, which we could rewrite as 9/4, and multiply. I get 108/4, which is 27. So 12 times 2 1/4 is 27. And then I could figure out what 8 times -1/2 is. Well, that would be 8/1 times -1/2. So 8 times -1 is -8. 1 times 2 is 2. And -8 divided by 2 simplifies to -4. So 8 times -1/2 is -4. And we could rewrite that as 27 minus 4, which is 23. Or we could just recognize that 27 plus -4, we're adding different signs. So we subtract to get 23, and the sign of the number with the greater absolute value is positive. So the answer is 23 is his final score. Example 3. The temperature at 4 p.m. was 2.5 degrees Fahrenheit in a lab freezer. It dropped 0.75 degrees Fahrenheit each hour for the next 4 hours. What was the temperature at 8 p.m.? First, let's start with finding what the change was. We're told that a temperature drops 0.75 degrees each hour for 4 hours. So we're going to drop, that's a negative, 0.75 times 4 hours. That's -3. So the temperature actually dropped 3 degrees Fahrenheit. Now, where did the temperature start at? It started at a positive 2.5 degrees Fahrenheit. And we don't necessarily have to have that degree symbol in the middle of the problem. But we know it started at 2.5 degrees and it dropped 3 degrees. So let's just subtract 3 degrees to get where it ended, -0.5. So the temperature at 8 p.m., it was -0.5 degrees Fahrenheit.